Okay, so we've been working with graphs, and as we've seen them, we're looking at these characteristics. We want to talk about some of the main characteristics we see, ideally the three big ones being center, spread, and shape. But I also want to discuss to some degree the idea of clusters, gaps, and outliers when we look at graphs. In this graphical display, we see two histograms that are overlaid against one another. Recall, histograms have frequency on their vertical axis and the actual data on the horizontal axis. We're seeing in this particular set of graphs that we have two very distinct shapes. Let's discuss shape first. The blue graph would be non-symmetric. We would almost call this evenly distributed. Tapers off towards the end, but it doesn't have a very distinctive shape. On the other hand, the red graph shows a mound-shaped symmetric distribution. So you see shape is very important as we begin discussing the characteristics of graphs. Let's move on to these two graphs and their centers. I want you to think of the centers as the average sort of point. What point on the graph represents the average data point out of that set, or the middle of that data set? It's hard to see here with the numbers on this graph, but it is clear that the blue graph has a much lower center than its red counterpart. Moving on to compare the spread of the two graphs, the blue data is much more spread out than the red data. It has a much larger range, and the values are much more heavily weighted towards its ends. The red graph, much more of the data is centered in the, center of the graph. Therefore, its spread is much less than that of the blue graph. We're going to quantify the idea of center and spread in the next video, but for now we can derive those characteristics from the graph itself. Here we have a histogram which displays the number of CDs owned by college students. Clearly an old example who owns CDs anymore. We are looking at a graph, though, that gives us the ability to discuss a couple of features, namely gaps. Notice how there are areas where data is absent. Those we would call gaps. There are also clusters of data. Just below 300, there's a cluster. Just above 300, there's a cluster. And then last but not least, this graph may indeed show us, potentially, some outliers. And we have to really formalize our discussion of outliers. But for now, an outlier would be an extreme data point. And someone owning 500 CDs seems like it might be cause for an outlier. One of the first things you'll learn to mention when we look at a graphical display is its shape. Namely, is it symmetric or not? This first graph, the top one here, is considered to be symmetric and bell-shaped. I prefer the word mound-shaped. When we look down at the middle graph, this is said to be skewed left. Skewed is determined by the tail, how the data tails off and to which direction. This is skewed to the left or skewed negatively. The bottom graph then refers to a graph that is skewed right or skewed positively. Again, the tail shows the direction of the skew. Finishing up our discussion of shape when talking about graphs, we see that these three graphs are all unimodal, meaning basically there's one hump, one point at which the data mounds around. Here we see in this next graph a bimodal data where there are two humps, like a camel, I guess, and you see there are 2 points at which the data mounds around. That's all for graphical characteristics. We'll be using these terms as we write and speak about graphs we encounter in this class.